Okay, so unfortunately I didn't have my microphone on for a few of these slideshows, so we're going to go through this one like this. This should be easy for you guys. I know you've done scientific notation before. So what is scientific notation? Scientific notation is when basically you have really big or really small numbers and you write them so that a number between 1 and 10 is multiplied by a power of 10. So for example, we have 110,000 right here, 110,000 meters. If I want to convert that to scientific notation, it's all about moving the decimal place, which even though there is no decimal place in this number, we of course know it will be at the very right end of the number. So to make sure my leading number is between 1 and 10, I would need my decimal place to be here. So it should be 1.1. And then times factor of 10. How do I know there's a 5 there? Well, I just count the decimal slides I went through. So the decimal start at the far right end, that'd be 1, 2, 3, 4, 5 slides to get me to 1.1. Positive exponents represent bigger numbers. Here we have a small number. We're going to move our decimal 1, 2, 3 times, and 3.78 will be, of course, the leading number between 1 and 10. And since we moved our decimal place to the right, representing a small number, we should have a negative exponent. To convert out of scientific notation, simply move the decimal place left or right. Move it left for negative exponents and right for positive. Just think of the reverse of what you just did there. So 1.23 times 10 to the negative 4. Okay, well, negative 4 tells me that should have been a small number, so I should be going to the left. So that should be 0.000123. You can check. That was 1, 2, 3, 4 decimal slides representing a small number, so it should be negative. All right, now adding and subtracting with scientific notation. You might think, why bother? We have these fancy calculators that can do this for us. But you won't always. I know in my own AP physics class, there's a portion of the test where they are not allowed to use a calculator. So this is not very difficult, but we do need to make sure we can do this. When you are adding and subtracting, you simply have to make sure that the exponents match before you add or subtract. Looking at this example down here, 4.35 times 10 to the positive ninth is a much bigger number than 10 to the 7th. So I can't just ignore these exponents and say, oh, I've got two numbers that are about 4 and subtract like that. Nope, got to change the exponent first. I can pick either way to change into. I can keep the 10 to the 9th, or I can keep the 10 to the 7th. I believe here I kept 10 to the 7th. So if I'm changing my exponent from 10 to the 9th to 10 to the 7th, okay, well that's 2 factors of 10, going from 9 to 7, and my exponent got smaller. So if it went from 9 to 7, 9 is bigger than 7, my exponent got smaller by 2 factors of 10, then my leading number should get bigger. So to make my leading number bigger by 2 factors of 10, I'm going to move my decimal place twice to the right. So that would give me 435 times 10 to the 7th. Now I can ignore the exponents since I made them the same and simply subtract this problem, where we get 430.98 times 10 to the 7th. I'm not sure if I've gone through significant figures or not yet, but depending on whatever order we do these notes in, with correct significant figures, you will have to look back at your original values. 4.35, okay, there's no zeros to worry about there. That is clearly 3 significant figures here. Pause. Okay, so we get 430.98 times 10 to the 7th. So we get 430.98 times 10 to the 7th. Now, I'm not sure if we have or have not talked about significant figures yet, but since this is an adding or subtracting problem, I would have to compare the precision of these numbers to figure out where I should round. And I have the right number, or the okay, now I'm not sure if I've gone through the significant figures notes yet or not. Depending on, every year we do things in slightly different order. Okay. Every year we do things in a slightly different order, so I'm not sure if I've gone through the significant figures notes yet or not, but assuming that I have, if I haven't, just hold off until we go through those notes. This will make a lot more sense later. But if we have gone through significant figures, you got to realize this is an adding or subtracting problem, so I have to round to the least precise number. And in this case, the 435, that does not even have any decimal places after it, especially since we have to have our matching exponents here. So 435 is less precise than 4.02. So my least precise digit here is really the ones digit where this 5 would be. So I would have to round to that spot. So 430.98 would round to 431. And that would have the same precision as my least precise number. Now this is fine for significant figures, but it still isn't really correctly put in scientific notation, since we said the leading number should be between 1 and 10, and 431 is clearly much bigger than 10. So we move our decimal place again, and we get 4.31. In this case, we made our leading number smaller by 2 decimal slides by 2 factors of 10, so we need to make our exponent bigger by 2 factors of 10, so going from 7 back to 9. So again, to represent the same number, if you make your leading number smaller, like we just did here, you've got to make your exponent bigger. And then vice versa. If you make your leading number bigger, you've got to make your exponent smaller. Okay, pretty tricky problem, especially throwing the sig figs in there. That's really about as hard as it will get for any of the adding and subtracting. I think multiplying and dividing is a little easier, so let's go through that last slide. If you want to multiply and divide anything with exponents here in scientific notation, you simply add or subtract the exponents. If you are multiplying, you would add them. So 3 times 10 to the 6, and this would just be meters, times 2 times 10 to the 3rd meters, would of course, 3 times 2, you can do that without a calculator, that's going to be 6. And we're going to take our 6 and our 3 and just add it up, times 10 to the 9th meters squares. This would be like the area of a room, well, pretty large room. And we did really follow our sig fig rules here for multiplying and dividing. We just take the least number of significant figures, which in this case is just the 3, 1 digit, so 1 significant figure here. 8 divided by 2, of course we know that's going to be 4. If we want to keep our significant figures rules, we need, of course, the 2 digits, so we should put 4.0. And then dealing with the exponents, we've got 10 to the 6th here, 10 to the 4th here. If it's a dividing problem, you would subtract. So 6 minus 4 would be 2. And this is just our units, m for meters, s for seconds. Talk more about units later. But just simply leave it as meters per second, just like a speed. Miles per hour, meters per second. And there you go. That is adding, subtracting, multiplying, and dividing with scientific notation.